In a remote corner of the Tibetan Plateau, surrounded by some of the world's tallest mountains and deepest gorges, China is planning the world's most complex super dam, a hydroelectric mega project unprecedented in scale. If completed, the dam could generate enough clean electricity to power the United Kingdom for an entire year. Yet, the location is among the most inaccessible on Earth, with extreme terrain, harsh climate, and seismic activity posing enormous challenges. Beyond energy, this project could shift the geopolitical balance across South Asia, particularly impacting downstream nations like India and Bangladesh. For over 70 years, China has pushed the boundaries of engineering, breaking records across industries. Hydropower is no exception. The nation now has roughly 87,000 dams, a number driven by the needs of its 1.4 billion people and ambitions to accelerate development by redirecting major rivers. Mega hydro projects like the Three Gorges Dam demonstrate China's ability to tackle massive water infrastructure. But the proposed super dam surpasses everything to date. The need for electricity. China's electricity demand is staggering, about twice that of the United States and 8 times that of Russia. Currently, most of its power comes from coal, the dirtiest energy source. As China pursues net zero emissions, it is increasingly investing in renewables, solar, wind, tidal energy, and hydroelectricity. Hydro projects have the added advantage of providing stable, reliable energy at scale. Since the 1950s, China has developed tens of thousands of dams, including the Three Gorges Dam, the world's largest hydroelectric facility. With most domestic rivers already dammed, the country has turned its attention to international rivers, which it largely controls, giving it significant influence over water resources in Asia. The Tibetan Plateau, Asia's water tower. The Tibetan Plateau, often called the roof of the world, averages over 4,500 meters in elevation and spans an area 5 times larger than France. Its vast glaciers and snowfields feed many of Asia's most important rivers, including the Indus, Ganges, Mekong, and Yarlung Tsangpo. These waterways traverse multiple countries, supporting dense populations, fertile farmland, and some of the region's most productive agricultural zones in China, India, Pakistan, and Southeast Asia. Due to its massive ice reserves and the critical rivers it sustains, the plateau has earned the nicknames Third Pole and the Water Tower of Asia. Beyond its environmental significance, control over these rivers carries immense strategic weight. Countries with influence over the plateau's waters can harness renewable hydroelectric energy and exert geopolitical leverage, affecting water availability, agriculture, and livelihoods for hundreds of millions of people downstream. In essence, the Tibetan Plateau is not only a natural wonder, but a central factor in Asia's energy, food security, and regional politics. The Yarlung Tsangpo River. China's proposed super dam targets the Yarlung Tsangpo River, known in India and Bangladesh as the Brahmaputra. Originating at the Yangtze Glacier, the river flows over 1,000 km eastward before turning south into India and Bangladesh. It is the highest major river in the world and one of the longest. Its course through the Yarlung Tsangpo Gorge, a sacred Tibetan site, includes the dramatic Great Bend, where the river drops over 2,000 meters in altitude across a 7.7 km arc, a steeper descent than the Grand Canyon. This combination of height, gradient, and water volume creates enormous potential for hydropower. The gorge's remote wild environment has preserved unique ecosystems and even undiscovered species, making environmental protection a major challenge, alongside engineering. Engineering the super dam. China has considered multiple approaches to harness the river's power. One involves a series of dams cascading down the gorge, which would threaten biodiversity. Another, more feasible option is to bore a tunnel through Namcha Barwa Mountain, redirecting water from the river's upper reaches to lower elevations near the Indian border. This tunnel could carry 2,000 cubic meters of water per second, generating up to 300 billion kilowatt hours per year, 3 times the output of the Three Gorges Dam. The design might include multiple hydroelectric stations in series, allowing water to generate energy as it passes downstream. Despite the enormous output, the visible construction would be smaller than the Three Gorges Dam, as the gorge itself amplifies the natural power of the water's descent. Environmental and geological challenges. The Yarlung Sangpo Gorge lies in a highly seismic zone, part of the Indo-Tibetan Suture Zone, where the Indian and Eurasian plates collide. Earthquakes are frequent and historically severe. In 1950, an 8.6 magnitude earthquake caused landslides that blocked the river for 8 days. When the natural dam broke, a 7-meter high wave killed hundreds downstream. Future seismic events could pose catastrophic risks to the dam and populations in India and Bangladesh. Landslides are another significant hazard. In recent decades, glaciers and natural debris have repeatedly blocked the river, sometimes causing destructive floods. Any super dam failure could lead to unprecedented loss of life and environmental damage, compounded by its proximity to international borders. Geopolitical implications. China's super dam has profound geopolitical consequences. By controlling the flow of water, China could exert influence over downstream nations, potentially using water as a strategic lever. India and China already share a tense relationship due to border disputes and competition for resources. In 2020, skirmishes along the border resulted in the deaths of 20 Indian soldiers. A mega dam could further complicate regional diplomacy, particularly as climate change alters river flow and intensifies water scarcity. India is planning its own 10-gigawatt dam to manage water resources, which may help domestically, but could exacerbate tensions with Bangladesh. Downstream, the Brahmaputra provides vital irrigation and sediment to maintain fertile agricultural land. A large dam could reduce sediment flow, threatening crop yields and food security in Assam and Bangladesh, while altering river patterns, causing flooding or limiting water availability during dry seasons. Balancing power, environment, and technology. China faces the monumental task of balancing energy production, environmental protection, and geopolitical stability. The project represents not only an engineering feat but also a technological and strategic challenge, comparable to space exploration. Designing a hydropower system that maximizes energy while minimizing ecological disruption and maintaining downstream water flow is unprecedented. Despite the risks, the project appears to be advancing. Government planning documents include hydro development in the Yarlung Sangpo region, and official statements suggest the super dam could play a key role in China's net zero emissions strategy. The project's ambition, scale, and potential impact underscore China's determination to leverage its natural resources for both energy and influence. China's super dam on the Yarlung Sangpo River is arguably the most ambitious hydropower project ever attempted. With the potential to generate 3 times the electricity of the world's largest existing dam, it promises enormous renewable energy benefits. Yet the challenges are equally vast: remote terrain, biodiversity concerns, seismic hazards, and the geopolitical ramifications for millions of downstream residents. As construction planning progresses, the world will watch closely. The project is a testament to China's engineering ambition, but also a stark reminder of the complex interplay between natural resources, environmental stewardship, and international diplomacy. The decisions made here will shape the future of energy, water management, and regional relations in South Asia for decades to come.